Hello everyone, this is Dr. Sandhya Tapadia. Today we are going to look at geometric distribution using R. First of all, let us just quickly revise what is geometric distribution. A random variable x is said to follow geometric distribution if it denotes number of Bernoulli trials with probability of success p until the first success. So roughly I can say the random variable takes the value of number of trials required to get the first. So probability that x equal to k is p into q raised to k minus 1, where p is probability of success, q is probability of failure. It means probability that first success has occurred on kth trial. Okay, so probability of x equal to k means what? Probability of x equal to k means probability that first success occurs on kth trial. Okay, so the distribution function is p into q raised to k minus 1. So that is only about geometric distribution. Let us directly go towards the example and then we will see how we can deal with this geometric distribution in R. So let us check out this example. This is very familiar. Bob is a high school basketball player. He's 70% free throw shooter. That means his probability of making free throw is 0.7. Then what is the probability that Bob makes his first free throw on his fifth shot? So first success has occurred on fifth trial. So as per the formula, here probability of success is 0.7. So probability of failure would be 0.3. And we want to find out probability of x equal to 5. So by the formula, it is 0.7. Let us check out over here. Console, you can see. Answer would be 0.7 into 0.3 raised to 4. The formula of geometric distribution. Okay. So let us check out what do we get in R. Now in R, as you are already familiar with various distributions we have worked out in R, like binomial, Poisson, normal, etc. So everywhere we looked at 4 functions. Say for example, if we are looking at the binomial distributions, they were D binom, P binom, Q binom, and R binom. So similarly, here also in geometric distribution, we have dgeom, pgeom, qgeom, and rgeom. Okay, and their meanings are more or less the same. Only formulae and syntax differs with respect to the distribution. So, as we are aware, dgeom, it deals with the density function. That means it gives us the probability of x equal to k. Let us check out what is the syntax of this dgeom, and in this you can observe here that we are looking at the geometric distribution in this window for plots, files and plots. You can see the description for geometric distribution has been given. So if you look at these 4 functions, their syntax you can observe. dgeom takes value of x, then probability. Here, value of x is crucial. It is not as per our formula. I mean, x equal to k we won't have. Here, x means number of failures you need to enter before you have got the success. So if I'm saying that first success has got on the kth trial, it means in this function, I would be putting value of x to be k minus 1. And probability PROB is probability, and it is probability of success. Okay. And we will, I'll come to this as and when we look for the remaining functions like pgeom, qgeom, rgeom, and so on. So here, let us check out the same example in R. In source, you can see I have entered the command. As I said, we need to enter number of failures before the first success we got. Okay, first success has been got on 5th shot. So number of failures before that are 4. Okay, so let us run this command dgeom in bracket x equal to 4. Probability of success is 0.7. If I run this, you will observe that you have got the same 0.00567. in both the cases. Okay, so this function is working quite well. Fine. Let us move towards the next function, which is pgeom. It talks about the cumulative distribution function. That means it talks about probability that x takes value less than or equal to k, or even it calculates probability of x taking value greater than k. So I can use the terminology that value of x is at the most k and at least. Okay, so that could be in sophisticated language. So here on the right hand side in this window for plots, if you can see this pgeom, here you need to substitute q. What is this q? Again, q is number of failures you need to enter before whatever success you are mentioning. So this is q is number of failures, and then you need to enter probability. Okay, probability for success. And I mean, we won't go into details of this log.p and lower.tail, but yes, lower.tail will be required if we take probability of x greater than k. So by default, its value is taken to be true, actually. Okay. So let us check out it with the help of examples. What should be the probability that at most 3 shots are needed to get the success? What is probability that at most 3 shots are needed to get the success? That means we are trying to find out probability of less equal to 3. Okay. So probability of x less equal to 3 means we will be taking value 3 minus 1, number of failures. Hai na? The number of failures are at most equal to 3 minus 1 and probability is 0.7. And the function is pgeom. Here I haven't entered anything like lower.tail or anything because by default it takes true and it calculates probability of x less equal to k. And that lower.tail has the same meaning as we have seen it in the previous distributions. Okay, so let me run this command and let us check out the answer. Okay, the answer has come out to be say something like 0.97. Okay, let us check out the other way around. Okay, this was the probability for getting at most 3 shots which are needed to get the success. Now let us find out the probability that at least 3 shots are needed to get the success. So at least 3 shots are needed means what? At least 2 failures will be incurred. So q would be 3 minus 1, probability is 0.7. And here you need to mention that lower.tail is false. So that R understands that we are dealing with probability of getting at least some, I mean, probability that the random variable is getting at least some value. Okay, so that lower.tail equal to false should be written over here. And let us try to run the command. And you will observe that the answer which you have got is complement of the previous answer. This is 0.027. And the answer which we have got earlier was 0.973. Okay. So for at most, we had got 0.973. For at least, we have got answer 0.027. Okay. So that is the two versions of pgeom which could be used. So the same function at least, I mean, cumulative distribution functions of at least type and at the most types. Then comes qgeom. It deals with quantile function. Okay, so what is that? It calculates the smaller value of x for which probability that probability is greater equal to p. Okay, probability is at least, we are supposed to find it. I mean, if we have been given probability of x less equal q greater equal to p, we would be given with the value of p, and we are supposed to find out value of q. That is what it means. Okay, so let us work that out. And for geometric distribution, this is quite interesting. How, I will tell you. So let us work out one problem. So what is the smallest q such that probability that x less equal to q is greater equal to 0.5. Now I'm putting p is equal to 0.5. Okay. Syntax for qgeom is actually, we need to write p first and then probability of success. That two things we need to provide. Okay. Now here our probability of success was 0.7. Okay. And geometric distribution talks about of trials required to get the first success. Let us check out what the answer is over here. Let me run the command so that you will answer, so that you will observe that answer has come out to be 0. Before giving any explanation, I want you to observe the other version of this command as well. Suppose my p is now 0.8, which is greater than probability of success. Now 0.5 was less than 0.7. So are you getting that? See, if I'm saying that this probability x deals with number of trials required to get the first success, and probability of success was 0.7. So here, if I enter p which is less than or equal to 0.7, the answer returned by qgeom would be 0. That probability is greater than the probability of success, the answer returned would be 1. Check out for p equal to 0.8. So if I have p equal to 0.8, the answer returned is 1. In fact, we can check out for some more values. Just for fun, we can say. So for example, here, if I put say 0.69, what happened? Answer which I have got is 0. If I put 71, that I must get 1 because that is the probability greater. So I have got 1. Okay. So I guess because that p was 0.5, it means everything was failure. Probability of success is 0.7. So I'm not getting success at all. So the value returned was 0. Okay. And if I'm getting probability is greater than 0.7, it means I got the success then and there itself. In the first place itself, I got the success. Okay, so it returned 1. I hope you get the meaning of it. Okay. And at last, let's look at rgeom. As you are aware, rgeom, rbinom, rnorm, rpoise, they generate n random numbers from the respective geometric distributions. Okay. So here also the syntax is again, we need to give numbers, random numbers which we need, how many numbers we need, and probability of success. That would suffice. Use basically this rgeom function to generate a data, check out how the mean variance looks, how should be the plot of probability distribution, and so on and so forth. Okay. So say for example, you can just check out here the syntax of rgeom has appeared. It is n comma prob. So n is number of, how many random numbers you need from that geometric distribution. So how much should be the length of your data set that I can say, and prob is probability of success. Suppose I'm trying to get this 100 random numbers from geometric distribution. Run the command. Let us view how that data looks. It has generated some random numbers, 1, 2, 3, whatever. It has generated some 100 numbers. 100 odd numbers have been generated. Okay. And then we can check out for the mean of the data. Can look for the variance of the data. Can look for the summary, everything. Okay. And if you can see the above 3 lines, I have tried to plot. I have given the commands to plot the probability distribution curve. Okay, for the geometric distribution. Okay, so suppose taking again 100 data points, go to 100. So they are actually 101, but anyways, in dgeom, if I'm trying to get the probability distribution, x would be taking k minus 1 value with probability equal to 0.7. The syntax for dgeom. And let us try to plot k versus the probabilities. Okay, I run this command. can see the distribution curve. Zoom it. You will observe it more clearly. This is how the curve for geometric distribution looks. So R helps us, once again, we have seen that how R helps us to deal with various kind of, okay. So it would be better if you try your own hand at these functions, try out different examples with the help of commands in R, so that this would be more conceptually as well as far as proficiency of R is concerned. Okay. So with this, I would stop over here. This is Sandhya Kapadia signing off. Happy learning R. Bye bye.